Every week on Cyberwork, listeners ask us the same question. What cybersecurity skills should I learn? Well, try this. Go to infosecinstitute.com/free to get your free cybersecurity talent development ebook. It's got in-depth training plans for the 12 most common roles, including SOC analyst, penetration tester, cloud security engineer, information risk analyst, privacy manager, secure coder, and more. We took notes from employees and a team of subject matter experts to build training plans that align with the most in-demand skills. You can use the plans as is or customize them to create a unique training plan that aligns with your own unique career goals. One more time, just go to infosecinstitute.com/free or click the link in the description to get your free training plans, plus many more free resources for Cyberwork listeners. Do it. infosecinstitute.com/free. Now, on with the show. Today on Cyberwork, Paul Giorgi of XM Cyber helps us wrap up 2022 by discussing some of the most unusual and complex attack paths that he and XM have seen in the past year. We discuss some of the most common breaches and methods, as well as a number of attack paths that are the very definition of taking the scenic route, which is, of course, why they worked for so long. Also, tune in for some great advice about getting involved in the work of risk management and access management. That's all today on Cyberwork. Welcome to this week's episode of the Cyberwork with Infosec podcast. Each week we talk with a different industry thought leader about cybersecurity trends, the way those trends affect the work of Infosec professionals, while offering tips for breaking in or moving up the ladder in the cybersecurity industry. Paul Giorgi is the director of sales. I have a better bio for you here. Paul Giorgi got his start in cybersecurity in Southern California, with a few DoD and DHS government contracts mostly focused within network security in the late 90s. He moved to Columbus, Ohio in 2006 and joined Fishnet Security, I like that name, where he found his love for sales engineering and solution architecture. Since then, he has held many positions, including CTO, solutions director, and principal architect, focused on security architecture design, testing and integration, helping large enterprise organizations combat malware, ransomware, and other risks. So today we are going to be talking with Paul about XM Cyber and specifically some of the more unusual attack paths that they've noticed in their research and in their years. So last year we had a talk with people about some of the unusual tech that was being used on people who were visiting home for the holidays and traveling for the first time in a while. But today we're going to talk about unusual attack paths and things like self-driving fleets and so forth. So Paul, thank you for joining me today and welcome to Cyberwork.
Yeah, thanks. Great being here.
So let's start, like I always like to do, with your origin story. How did you first get interested in computers and tech? What was the initial spark of inspiration? How far back does it go?
Yeah, I grew up in the 80s where electronics were magical and speak and spell and these type of things were seemingly like these just magical devices. So my parents would get them for me, and the first thing I would do was take them apart. So it probably was traditional way to.
So you went straight to the hardware then. You wanted to see what was inside the guts of the machine.
I just always wanted to understand the way things worked. So I mean, opening it up, being like, okay, I don't know what any of these components are, but now I'm trying to identify things. So that was kind of where it started.
Okay.
My dad would always bring home his old computers from work. And so for me, I mean, it was early days of computing. So I remember like my first computer that I got gifted to me from my dad was an old IBM 8086 with the 10 hard drive. And I remember being like, this is amazing. And then a few years later, my dad was like, hey, this is now my retired 386. It's an old IBM too. And then of course I'm taking that apart and breaking it and playing with it. And I love playing with things. And then my dad would bring home all the software that he would have, and I would load it up and play with it. And of course, there wasn't Google or anything, so you couldn't like figure stuff out. You just had to learn by breaking and just doing things all wrong.
Yep.
Eventually, the world of modems and BBSs kind of like just blew my mind. The idea of like, hey, this computer over here is talking on 300 baud to this computer over here, and I could transfer files and messages, and then that just kind of propelled me into the world of computer security. Because as soon as I started thinking about hey, I can do this with this other computer remotely, I start to think like, well, what can I do that they don't expect? And how can I break things? And how can I do things unexpected? Kind of going back to that same mentality of when you get the speak and spell, break it and take it apart. And I just had that same sort of interest in what could be possible.
Now, it sounds like if you were able to sort of break these things, you were able to also put them back together then, I presume, right? Sometimes, maybe?
Not all the time.
Not all the time. Okay.
It's actually a really good learning experience to break things to the point where like, I cannot fix this. And this is why. This is the thing that I can't get past. And so that's a good experience in itself.
Did you were you also interested in like programming languages and software type stuff, or was it more the sort of the tech side of it?
That came eventually. I remember for my 5th grade Christmas present, wanting a copy of physical discs of Red Hat Enterprise Linux. It was wow. That was so. It was. I always kind of had like that type of like unusual interest in programming. I mean, I remember learning different, like BASIC obviously was one of the first languages learning. I learned Ada, kind of really didn't take off as a programming language. Visual Basic was another one that I got focused on. And so it would I always just love an inch deep and a mile wide kind of thing. So I never would call myself a programmer or anything, but I could script and I would write services and different API stuff and just enough to understand how it works. And as soon as I understand how it works, I would just move on to the next thing.
Chase the next exciting development point. Well, there's a lot of benefit to that, and as we can see here. So I'm looking through some of your career highlights on LinkedIn. That's another way I would get to know our guests. And one job title comes up several times, both in your current role and in past roles. And I'm speaking of sales engineer. So I know many of our listeners use this podcast to help narrow down the type of career they'd like to have in tech or security. So can you walk us through in a broad way what a sales engineer's responsibility are? What types of skills and qualifications do you need to enter a job role like that?
Yeah, I mean, I may be biased, but in my opinion, I think sales engineering is really the best role in the world because you get to do all of the tech fun stuff, but you also have like the pay and a lot of like the extra perks that you get out of a sales role. So for example, I mean, I can't tell you how many like sports things that I've been to. I'm not interested in sports at all, but are like, hey, all these customers want to go see the Super Bowl or the Final Four. I'm like, I guess I'll go. And I don't know who's playing, but I'll go. And so like you get all those perks from like a sales, but you don't have the pressure of sales. Like when the team isn't delivering on the quota from like a sales perspective, they never fire the sales engineer. It's always the salesperson who has that pressure. So you get all the perks of that sales role, but all of the tech fun stuff of being an engineering role without the responsibility of actually expecting it to get it to work. So I can outlandish not claims, but I can be like, hey, these are all the things that you can do with this solution, but I'm not actually necessarily the one in charge to get it to work. I kind of sell the idea of the solution and what is capable of it and say like how it can fit in that organization or how it could solve their problem. And then more than likely, if something breaks or, hey, we're trying to get this stood up, it's not on my plate. I'm really in charge of just helping the sales team sell the solution and handling all the technical side of the sales process. So figuring out what the customer's struggling with, figuring out the details of their environment, trying to align use cases and testing and do proof of concepts and all of that type of stuff when it comes to the sales process, but you're on the technical side of it.
Okay, yeah, that makes more sense. I was having a hard time sort of visualizing it in my head. So, for instance, with our skills platform where people learn cybersecurity skills online, like the salesperson is like, you need this, and they say yes, but they don't necessarily know how to do all the walkthrough. So they bring in the person from the content department. Okay, gotcha. And so you're sort of showing the tech walkthrough of what you guys do. Is that right?
Yep. Yeah, exactly. A salesperson's whole job is just to sell a thing. They may or may not even be familiar with it or even how to turn it on. They don't know how it's going to help that organization, but their whole job is just keep making phone calls until someone says, hey, that sounds interesting. And as soon as they have that interest, then they bring in the sales engineer to kind of figure out like, hey, they said they're interested in our thing. Figure out why they're interested in it and let's try to sell it to them.
I imagine that it helps you to sort of learn new scenarios within your products as well, right? Like because you're not just doing the thing that it was built to do. Now you're sitting there, they're saying, well, we need it to do this one particular thing. And you're like, well, no one's ever asked for that before. And so then you have to kind of like sit with the product and figure out how to make it work. Is that right?
Yeah, kind of. Over my career, I've switched between two different types of sales engineering roles. There's the VAR side of things, so like the value added resellers. Like I worked at Optiv and Fishnet and Defy Security, and these are all like kind of we'll sell you anything. So when you're doing sales engineering for that's really difficult because one meeting you're talking about data security, the very next meeting you're talking about network security, then the very next meeting you talk about GRC, and then the very next meeting you're talking about cloud security. Yeah. So you have to be an expert at everything. But then if you look at like my LinkedIn experience, I've kind of throw in different vendor gigs throughout everything. So I'll get the experience of, hey, whatever, and I'll just be a generalist and I'll get kind of really excited about a certain area and then I'll focus in on it and I'll join a company like I was at Exabeam for a while. I loved user anomaly detection and behavioral analysis and SIM and those type of things. And so I was like, you know what, I'm going to jump from where I'm at Optiv and I'm going to take a sales engineering role at Exabeam. And I did that for a couple of years. Then I went back to Defy or back to VAR at Defy. And then I really got really excited about breach and attack simulation. And so then I was like, you know what, I want to just really focus on breach and attack simulation for a while. And that was about 2 years ago. And that's how long I've been at XM Cyber. So it is, is really cool hearing how all of the different ways that customers are interested in things. But when I'm out of VAR, I get to see like what I'm hearing most commonly. Like, man, people are really interested in UEBA. I'm going to jump into Exabeam. And then, man, people are really talking about breach and attack simulation. I love it. I'm going to just really focus on that in the next couple of years. So that's where I'm at.
That's cool. Now, putting some sort of fence posts around that, what does an average work day look like as director of sales engineering at XM Cyber? Do you have certain types of responsibilities that happen first, beginning of the day? Do you have certain quotas or things like that? How much time is spent interfacing with clients, and how much is spent interfacing with your technical team, things like that?
Yeah. So as a director of sales engineering, I lead our sales engineering team. It's still growing, and I support the Americas team. So I've got a couple of other SEs that report up to me. From like the sales engineering world, I still am very much a coach player model where I think that if most people saw the way I interact, they would have a hard time differentiating, like, is he a sales engineer or is he the manager director of the sales engineers? Because I still am very much doing sales engineering stuff. So I'll focus on those type of responsibilities. So at any given time, I have anywhere from like 5 to 10 POCs going on. So during those POCs, they usually have some sort of like, this is the stuff that we're accomplishing this week. This is the stuff we're testing. Here's the stuff we're capturing. So regular POC processes is definitely a large part of it. Upon completion of a POC, you have to put together all your findings and deliverables and then review them in a presentation, usually with some sort of executive sponsor. So that's a different role. You always have to be kind of making yourself aware of customer environments because, like we were saying, there's a lot. I mean, I'll work with one customer and they're like, we're fully in GCP. Everything's functioning in GCP. We want to simulate attacks within GCP. I'm like, okay, great. Google Cloud environment. I'm familiar with it. And then the next day I'll talk with somebody and they're like, we can't stand GCP. Everything's Azure. So to be a really good sales engineer, you have to be familiar with the customer's environment. So I would say that a good large portion of my time is just getting familiar with customers' environments, their solutions, their struggles. I have lab environments of all of those main cloud providers. I've got a huge lab environment at my house. We have lab environments at XM. And the whole goal is just for me to be able to get hands-on familiarity with what our customers are dealing with. So that way I can help them address their struggles and their problems directly without just ambiguously saying, hey, I think this will help you figure it out. So I like to test it first before saying the solution can do that or solve this problem.
Yeah. And hearing that you have so many different irons in the fire at the same time, I'm imagining there's a strong sort of project management component of this, you have to really be like very, very organized in terms of like all the different pieces that are in progress. You're asking for a test on this thing, or you're coming back, or you're answering this question while also getting data from this other group. So I imagine it's sort of a logistical challenge as well in that regard, right?
It is. Yeah, you definitely have to be organized. Luckily, most sales teams have a lot of different tools to help you track that. I mean, Salesforce is obviously a common one that you create an opportunity and you put all your notes and you're tracking all your activities in it. Sure. So there's ways to just, if you struggle with being organized, that there's crutches to help that. If you learn how to use those crutches, you don't have to be the most organized person in the world. There definitely is. You have to be on track of, okay, we started this POC on this date. We're going to end it on this date. They have this date to make a decision. It's for this budget cycle, and trying to keep track of all of those. I use Evernote.
You could tell that I was asking that question for myself, right? Yeah, no, I'm not that organized, and that does make it sound a little more accessible. So that's good. Thank you for that. So by the time this episode airs, we'll be well into 2023. This will probably be late January. But as we're recording it, everyone is days out from checking out for the end of the year holidays, which is why we're taking stock and kind of looking back at different aspects of security in the year 2022. So, your topic of choice was some of the strangest, most unexpected, most potentially dangerous attack vectors that you and XM Cyber encountered. So let's start out, Paul, by taking a high-level view here. What were some of the biggest overall trends in cybercrime this year, especially as regards breaches and vulnerabilities? What were the main areas that XM was focused on?
Yeah, 2022 was a weird year. We had a lot of weird, high-profile vulnerabilities. Think about Log4j, Spring4Shell, Felina. So there was a lot of really high-profile vulnerabilities where, if I think back, most of the time I feel like there would always be like one big one a year. And for whatever reason, this year had a lot of them. So within breach and attack simulation, within what we do with attack path management at XM, really focus on trying to see like, how can this new vulnerability introduce risk or be operationalized by an attacker to put your critical assets at risk. So that definitely played a lot with it. We have a lot of organizations really assessing the whole stuff that's going on in Ukraine and Russia, trying to evaluate like, hey, we have a sizable workforce over in Ukraine. What is the risk to our critical assets, maybe somewhere else in the world from Ukraine or from Russia? And then being able to simulate like, let's run through some simulation saying, okay, of all of the people that we have in the Ukraine, if they were an insider threat or their account gets compromised or an entity of theirs gets compromised, is there any risk to maybe some sort of critical asset holding intellectual property sitting maybe here in the States? So there's been a lot of questions around that, especially with XM. They're saying, I want to run a scenario where all of my workforce in Ukraine is all compromised. And then what happens and what risk is introduced and what are ways that they're able to get to my critical assets? So that's another one. Third-party risk was a really big one as well. You think about like a lot of the different breaches that we had with SolarWinds, Messiah, trying to figure out like, okay, how do I, as a security team, prevent these type of things from happening? Like we're deploying SolarWinds, and how am I supposed to be able to assess how secure these solutions are or the risks that I'm introducing of these solutions that they're deploying? So assessing cyber risk from a third-party perspective is also a really big one. The last two, ransomware attacks. Everyone's talking about ransomware attacks. And I feel like
ransomware,
a good 90% of all the POCs that I have going on right now say, hey, one of the scenarios I want to simulate is a ransomware attack. I want to see what happens in my environment and how prone I am to be hardened against a ransomware attack, or maybe the opposite. And then the last one is vulnerability prioritization. I think we now have seen that. I think I was looking at the CVE totals for this year. Again, they went up pretty much every single year. We have more and more. I think we're 23,000 vulnerabilities for 2022. It's just impossible for teams to actually patch and remediate and track all these anymore. So prioritizing these efforts, figuring out a real way to address vulnerabilities in organization without just scanning everything, taking kind of account, saying like, hey, we have 4,000 instances of Log4j that are vulnerable. And then like you have the board and executives saying like, well, what does that mean? Like, does this put us at risk? Like, can you put this into more terms that I can understand. Don't just tell me how many instances we have of it. So I think 2022 those were all the big ones that I can think of. But I'm sure there's so many others that it was just a fun world. I think another big one was we had a lot of people returning from remote workforces coming back into the offices. So we're now starting to shift ways that we have implemented, like maybe zero trust in different network environments, and maybe shifting them around a little bit. And maybe instead of doing zero trust, maybe introducing more like macro segmentation and adopting different technologies and strategies like that, where, hey, we didn't have a chance to try that out 2 years ago because everyone was distributed and working from home. But now that we have a better understanding of it, now we're going to see if all of these things that we've been designing over the last 2 years actually work for all of our workforce that are back in the office.
Yeah, I was going to ask that. You're absolutely right. I mean, we've just seen a barrage of like just recurring like issues, vulnerabilities, ransomwares, and things like that. Do you get a sense, based on how chaotic this year was in that regard, that lessons were being learned? Or is this the sort of thing where people just had to really like take an L, and then a year or two from now everyone's going to kind of get their footing back or something like that? Do you feel like that this actually came to something at the end of the year?
Yeah, I think so. I think there's always lessons to be learned. I think that's why I love breach and attack simulation so much. It's like, how about we teach you those lessons without you going through the pain of like customer data loss or intellectual property loss? So I think that any time that we're dealing with something new, there's a chance for us to learn from it. And I think that we definitely learned a lot of things. I think everyone's still trying to figure out how zero trust fits in any zero trust network architecture fits into most organizations. And I think that there's been some big failures. A lot of people followed a vendor and said, hey, this is our zero trust solution, and then didn't realize that it's more of a methodology, and then really just had it fail. Saw the same sort of thing with DLP programs like years before that, where, hey, I bought a Beat DLP tool and it does DLP for me. And then you realize like, well, you can't just buy a tool. You have to like do data lifecycle management, and you do data classification and all these other things. If you don't do those things, then a tool's not going to help you. So I think that as we're learning from 2022 and all the different things, from the overwhelming vulnerabilities, the shift back to the workplace, the failed zero trust network architecture, and then maybe kind of coming together with like, hey, it isn't zero trust, but it's close. And I think that this works better for us. And I think that that's kind of the state that I see most organizations in.
Yeah. Now, I just got off a previous recording with, another guest who was talking about the recent Pentagon directive to move, DoD towards a zero trust solution. Do you have any thoughts on that particular implementation? Like we were trying to figure out whether or not like the deadline was reasonable, considering just how many sort of input points there are.
Yeah, I mean, I worked in the DoD for a while. That's where I got my start. And they're always a trailblazer, but the last to adopt. they talk a big game, and then they never actually do it. So I think that this is kind of another example of that, where they need to be some sort of authority and put together on paper frameworks and guidelines, knowing full well that they aren't going to adopt them. I put together an IPv6 architecture plan. It was 2002, and everyone was like, "Hey, we're running out of IP addresses," and this was for a large DoD instance. It was a whole Class B, and we had this whole plan to do IPv6. To this day, it still has not been implemented, but a lot of like the stuff that we wrote down and reference material and plans was beneficial, and it's good for us to walk through that. And I think that that's kind of the same thing we're seeing with the Pentagon's implementation of zero trust. It's going to be a great reference material, but we're never going to see it actually implemented.
Boy, the time scale of that 2002, because I started working here in 2012, 2013, and IPv6 at that point already had the feeling of like an environmental catastrophe. Like, we have to implement this now. And it's like, here we are 10 years later. And then you're telling me 10 years before that, they were saying it would be a good idea if we didn't implement this right now. So
well, 2002, no one was really using NAT. NAT was this thing that was like, hey, everything just has a public, like a non-RFC 1918 address on it. So I managed multiple Class B networks, and every single computer had a public facing IP address, which you think about like how that is today, it just blows your mind. Not only is it just a waste of routable IP addresses, but it's really insecure. So now that we all are hiding behind NAT, and some organizations have hundreds of thousands of devices all underneath a single IP address, it really lessens the severity of the IPv6 evolution.
Yeah, we're on to other bigger fires now.
Exactly.
So compared with some of the recurring examples that we mentioned previously, were there any especially convoluted, complex, or just plain strange examples of security pivots that led to successful breaches and exploitations that you saw tried this year?
Yeah, I think that there is actually a lot of them. I think my favorite ones combine multiple different types of things. So I'll give you an example. I don't like, or I prefer attack paths that don't just say, hey, you use this vulnerability to get to this machine, and then from that, that compromise this other machine. I like to look at real world examples of compromises, whether it's Colonial Pipeline or any of like the big ones, and see what was it that happened. And you look at, hey, a credential was where it started, and it was just a compromised credential. Either they found it on the dark net, or just sitting in some repository, or a fish. However they got it, that's the start of the breach, and that's like that initial breach point. And then from there, what's possible, and then what's the attack surface from that compromised credential. Then from there, positioning yourself like, hey, I could leverage these entities in this way to do this thing, and then from there I could position these entities to do this in this way. So kind of prefacing all of those things coming together to build out attack paths. So a couple that I saw that were really interesting, we had a really large insurance organization run through different simulations to test out some digital transformation that they were working with. And they realized that, hey, there is a really common choke point. We call them choke points. You look at attacks, they all kind of converge through this one entity. And it was all this one developer system. So this one developer system was not only misconfigured, but it had a vulnerability. So it has a misconfiguration where it was looking for a proxy server, and they didn't use a proxy server in that environment. So an attacker could see that broadcast and say, I'll be your proxy server, respond to it, and basically allow themselves to be a man in the middle. Once they positioned themselves to be a man in the middle, there was also a vulnerability on that same machine that anything that you positioned from like a Windows Update perspective would get run from the Windows Update subsystem. So you could drop any executable and say, hey, here's a Windows Update for you. And it would just say blindly, like, yes, I'll run it. So you can take a piece of ransomware or malware or whatever you want to do, because you're positioned in that position as a proxy server. As you're seeing that traffic and those Windows Updates, you could just drop a different executable and it would run it. So we saw all of these attacks coming through this one developer's system because it was misconfigured. It had that vulnerability. But what was scary about it was that developer system was really risky, because developers are lazy in a good way. They're meant to be efficient. They don't want to spend a lot of time doing two-factor authentication. So they introduce shortcuts, and a lot of these shortcuts rely on private SSH keys that don't have any passphrases sitting in just really open areas of their system. A lot of them have their AWS credentials sitting in their AWS CLI, so they could just quickly do things without actually having to authenticate anywhere, and it's all just done from command line. They often will have different API credentials that's sitting there. So we saw that, so if once that machine is compromised, we are able to compromise a good 90% of the rest of the environment, both in cloud and on-prem. So we realized that, hey, not only is it relatively easy to compromise that machine because of the vulnerabilities and the misconfigurations, but from that one machine, I could pick any entity in the whole environment, of which there are hundreds of thousands. I can click on like an S3 bucket of theirs, and I say, hey, look, like you could trace it back to that one same developer's machine. And then you click on this EC2 instance, and you look at attack, and you're like, hey, there's that developer's machine again. So what we did, we patched it. We introduced a lot of just, hey, we need to clean up your hygiene from a development standpoint. And we were able to reduce that scenario from 90% of their environment regularly being compromised down down to only about 12%. So it was a huge reduction in attack surface because you get rid of those choke points, you remediate those one choke points. And instead of just saying, we're going to patch all vulnerabilities everywhere, you now have this ability to say that one developer's machine is really risky to us because of everything going on it. I need to just fix the couple of ways that we've seen that machine get taken over and then used to compromise other machines. So that was one really good attack path. I mean, we did for the month of October, Cybersecurity Awareness Month. We had, I think it was every single day, all of us from the field were sharing interesting attack paths. And what I just heard from our marketing team is we're actually putting together a book. So we're going to have a book with all of these different interesting attack paths showing how people don't necessarily think in the way that you think of from an attacker standpoint. From like a security defensive standpoint, you look at everything kind of myopically. It's like, is this system secure? Yes. Okay. Move over to this next entity. Is this entity secure? Yes. Move over to the next. But it doesn't necessarily mean that there isn't still something on that machine that would allow you to then compromise this other machine. And that's really where attack paths become important.
Now, is there a when I hear stories like that, and we do hear them a lot, and we hear about this is the most interesting one too, because it's a developer who's there right now, so it's an active account. A lot of things that you hear are like, well, there's this this old user that hasn't been used in 7 years, and somehow we didn't even think to scan for it and things like that. Is there a speed component to this as well, or were they able to kind of leisurely, set up this proxy server with the developer and sort of make all this movement within the span of like a couple days, couple months, or had that been in place for a long time when you guys found it?
Yeah, I think it had been in place for a long time. The problem is as the developer continued to do more and more bad hygiene stuff, the risk just kept getting greater and greater. So while you could have always compromised that developer's machine, it really kind of kept getting worse and worse as the developer just kind of continued to use bad practices. So
got it.
I'm just going to start putting all these private SSH keys for all of our Kubernetes cluster sitting in this folder. So you compromise one developer's machine, you now own all 8,000 nodes of their Kubernetes cluster because all of the SSH keys are sitting there and there's no passcode. And I don't know, it was just a escalating series of events that just made that developer's machine very risky.
A case study of putting all your eggs in one basket. That's amazing.
Exactly. Yep.
So one topic that was brought up before the show was the Uber breach back in September, and going from that, a vulnerability that you found that would allow a hacker access to a server responsible for controlling unmanned vehicles. So a few years back, one of my earliest guests on the show was Alyssa Knight, who worked heavily in this realm and up to and including writing a whole book about hacking connected cars. So at the time, one of the most shocking things we discovered was that some of these vulnerabilities could have been very easily and cheaply mitigated, in some cases for the cost of a $2 FireWire cable or some such, and the problem could have been avoided. So what in your and XM's experience is the current security landscape for connected and unmanned vehicles? Are we still suffering from the, for want of a cable mindset, or have the struggles changed and taken new shapes since then?
Yeah, I mean, I think that there's a lot of topics that you hit on there. So the Uber breach, I love using it as an example because that is also a really great attack path example where most organizations aren't evaluating their risk from the lens of like an Uber breach, where you start from, I think it was a compromised credential that happened from phishing that led to them being able to access their internal network. From there, they're able to access another system. And then eventually they got to some really sensitive stuff. So that's a great example of an attack path where the breach point wasn't necessarily some publicly exposed vulnerability. It was a credential that was compromised. So understanding kind of what would happen if this credential were compromised, or this third-party credential was compromised, or an insider threat, running through those is a great start, or a breach point for an attack path, and then carry out and combining behaviors and vulnerabilities to then see what's possible from that credential. So I love that example. The whole, like, what is it about the IoT stuff, and hey, is there a $2 cable that we're just all neglecting? I guess from my perspective, I see a lot of focus on compensating controls without even the awareness of how like direct remediations could actually play a role in fixing it. Everyone's so focused on the shiny tool that's supposed to prevent that from happening, I don't think. I guess I would say, I think there's more people focused on the shiny tool to prevent bad things from happening than they are actually focusing on the actual remediation itself. So I'll give a couple of examples, like
Sure.
XDR and EDR and tools. I mean, they're great. I love them. But over and over, we're seeing that they're relatively easy to get bypassed, whether you're doing anti-kernel unhooking. I mean, there's a lot of different ways for you to bypass an EDR solution. So why do we still have so much trust in these solutions to prevent all these bad things from happening? I mean, right. Configurations, bad hygiene, vulnerabilities, bad user behavior. It's all like this understanding of, hey, well, we have EDR, it'll protect us. I'm like, oh my gosh, why are we spending so much time fixing that when we should really be focusing on, why don't we patch that system? Why don't we address the misconfiguration? I can't tell you how many organizations I go or I do POCs with, and we see just bad credential hygiene. Cache credentials sitting cached in LSAS of domain admin accounts. I'm like, if this machine were compromised, I could use a tool like Mimikatz or Lasagna, or just dump it manual out of LSAS, and now I have a domain admin credential. There should be no reason why I should find a cached domain admin credential, because you should never be allowing interactive logons on any sort of domain admin credential. That's just bad practice. But instead of disabling that use, because there are GPOs you can enforce saying do not allow interactive logon from domain admins, or putting users in protected user groups. And there's so many different ways. Instead of actually applying these direct fixes, we spend more and more money and hire more and more security engineers and architects to have all of these compensating controls, when in reality, the direct fix is probably easier than all this other stuff that you're doing. So I feel like us as a security world, like because it's new and there's so many new solutions, we're like chasing the next shiny thing. We're so much more interested in all these compensating controls, and the sexiness of actually fixing the true risk is deprioritized.
Yeah, no, yeah, absolutely. And I think it always ends up coming down to thinking through the problem before throwing money at it, or saying, well, everyone's doing this new thing, so we better do it as well, and stuff like that. So yeah. So obviously, we're talking about a lot of stuff today here. So things like smart cars and IoT devices, server controlled unmanned fleets, it's all pretty much here to stay. So we're going to have to learn to make them safer. So I guess you were already sort of talking about that. What are some high level across the board security recommendations you have for purveyors of these types of hackable and potentially dangerous technologies in the new year?
Yeah, I think that the way that I can relate this or compare this to is, I remember like hyper converged infrastructure. Remember when like VoIP was starting to take off, like, oh, we can't have voice phones sitting on the same networks as like all of our computers and stuff. We need to have these separated and have separate systems. And then when hyper converged came around, and like you have your storage SAN running IP, and it's in the same IP space as your voice, and then the voice is also running right next to your computers. And then, oh my gosh, the consumerization of IT came around, and everyone has their phones and their iPads all sitting on the same Wi-Fi network. So I think of this as just the next evolution of that same sort of mindset of, oh no, there's this new thing. How do I address it? We need to start thinking more holistically around risk. And so the reason why I say that is we can't just myopically and from a real focused area just assess IoT or just assess smart cars, because that's not the way an attacker looks at it. They're opportunistic, and they're going to say, hey, if I can do that thing over here to then get me over here, I'm going to do that, and whatever is the least path of resistance. So I think that we need to start evaluating holistically across everything. Like, I don't think that there's a lot of people who are evaluating IoT securities in regards to like, hey, let's look at how Active Directory and my Active Directory environment plays a role within IoT. I think that we aren't really looking at that. We're looking at more like open source and what hardware and what OS and what vulnerabilities are on it, but not necessarily like how that combined with Active Directory might play a role. Or, hey, you know what? Like if a credential or some sort of artifact is compromised in that IoT environment, what could then be leveraged within the cloud environment or within my data center? Or from what choke points can I jump from my IoT network to other networks? And there's so many ways to think about things that I think most organizations are still struggling with just the idea of like IoT security or smart cars, and when you look at where your critical assets are, where your likely breach points are, and then all of the ways that all of those other entities play a role in compromising your critical assets from those breach points, then you really start thinking the way that an attacker looks at things.
Yeah. Well, okay, let's start thinking about that. So for listeners who want to get into the work of creating and implementing solutions for vulnerable technology like unmanned vehicles and more, can you talk about the combination of work experience, certifications, and tasks they should be aiming for in their daily work life to get them sort of on the right path here? Are there certain experiences or backgrounds that these types of companies are looking for?
Yeah, I've always been a proponent of just playing, get certifications, get experience, get stuff in the lab as being the better way to learn. That was kind of the way I went. I started going down the college path. And then it was, I don't know, about a year into college, I realized that I was like, man, I have the job that all of these people who are sitting in my class are hoping to get after it. I just really need to focus on the job and get as much on the job experience training as I can. So I'm technically a college dropout. And from there, I really just focused on as many experiences and as many certifications as I could get, and really just use that because now that I've been in this industry for, I don't know, almost 20 something years, almost 30 years or so, you end up looking at, okay, there's a lot of people who can have their parents pay for a 4-year degree somewhere, and then they'll have some sort of computer security title. There's also a lot of people who are chasing the money, where it's like, hey, cybersecurity pays really well. I'm going to get into cybersecurity, and that's not somebody that I think has like the best ability to excel in this career. I think you need to find somebody who's just passionate about whatever it is that they're securing. So I don't think you jump directly into cybersecurity. You kind of need to have some sort of fundamental understanding underneath it. So whether you like networking, or whether you like application development, or maybe you like cloud architecture, or maybe even like DevOps, there's security components to all of those. And think about security as kind of being like a 102 or a 103 class, or a 201 or a 301 class in college, where to really get to that next step, you have to have an understanding of how things work, because you can't just jump into application security without understanding how applications work, or you can't jump into network security without understanding how networks work. So my best career advice is just do it, break things, get a lab set up at your house, get many things in it as you can, break them over and over and over again until you understand how they break, and then see how you can fix them. When I interview candidates, I usually spend more time talking about what they're naturally interested in, rather than I am like what college degree they have or what certifications. Like what are you playing with in your home lab? What makes up your home lab? Have you played with whatever the latest cool tool is out there? And I'm like, hey, did you see this new sandboxing tool? Or did you get a chance to play with this new Helm chart that's coming out? I mean, there's so many things that if you are really passionate about what you're doing, you're just going to naturally start finding ways to be successful at it within the security industry. And I search for those people who are just passionate enough about it when they aren't working, they're still interested, and they just naturally have this inclination to play with things, learn about things, and break things.
Love it. That's great advice. So as we wrap up today, I want to ask, can you tell people a little bit more about XM Cyber and your current offerings, and if you have any new projects or unveilings that you're looking forward to in 2023, feel free to toot the trumpet about it.
Yeah, so we at XM Cyber fall underneath the category of breach and attack simulation, and it's a very wide category. There's solutions doing like security control validation. There's solutions like automated pen testing, and while there is a little bit of an overlap, we've been really focused within attack path management. Attack path management is evaluating all of the possibilities an attacker could do without actually doing them. So what's great about our solution is you could run a scenario every single day using the telemetry we're collecting and saying, okay, of what we know about the environment, these are all the ways an attacker could compromise your critical assets. I use the analogy of Google Maps all the time. Think about Google Maps. When you're in it, you have to define two things. You have to define a starting address and a desired destination. And Google Maps will say, this is the recommended route. This is a route that avoids tolls, and this is a route that's more scenic. We do that same exact thing, but from an attacker's perspective. You define a breach point, whether it's a compromised credential, like in the Uber situation, and then you define a critical asset, and we'll say, okay, these are the 6 steps, or these are the 10 steps. That's possible from an attacker's perspective, giving that insight. So remember, we were talking about lessons learned when things break or you have these compromises. You now have the ability to learn these lessons every day without the pain of recovery and notifying customers and that type of stuff. So overall, we've been trying to focus and expand our capabilities within breach and attack simulation. We acquired a company called Cyber Observer about 6 months ago. And what they do is they evaluate your controls. So remember that what's possible from an attacker's perspective. Now we're going to be able to start showing how complex the attack path is and taking into account the controls that are on there. So we were talking about bypassing EDR earlier. If there's a step that we say, hey, this is possible on this entity, we're now going to be aware that, yes, you have CrowdStrike or Sentinel-1 or whatever the EDR solution is, and say, okay, there's a policy preventing that from happening. So we're going to increase the complexity. So now you're going to have the awareness of your tools and the role they play at preventing that from happening, but still aware of the underlying risk, knowing that, going back to my point earlier, those EDR tools and those compensating controls aren't a direct remediation, kind of a safety net, preventing, like, if something bad does happen, hopefully something's going to catch me and break my fall. The last thing that that we just started doing, we're supporting Kubernetes now. So a lot of organizations have a lot of critical assets or a lot of concern around breach points within Kubernetes. So we're getting that capability nailed down. And then I think that our manifest destiny, kind of like looking at what's probably next for us, is around attack surface management. There's a breach and attack simulation. There's a whole category of solutions within attack surface management. So it's that dynamic discovery of likely breach points. In our solution, you have to define them. You can define them with a rule or some discovery rule. But for us to say, hey, I don't know where a likely breach point is, we can't really do that very well. So I think we're going to start getting it more into attack surface management. So we can just say, click on, I could type in a domain name. I could just say acme.com. And then we discover, hey, these are these exposed systems, and this is this vulnerable system over here, and this is this public-facing DNS server that can be abused this way. And you could just say, okay, run a scenario from the breach points that are likely to happen from a public-facing environment. So I think if I had to guess where 2023 is going to leave us from our capabilities, I think that that's the next step for us to be able to understand what are likely breach points and then just define scenarios based off of that.
Awesome. So one last question for all the beans here. If listeners want to learn more about Paul Giorgi or XM Cyber, where should they go online?
Yeah, xmcyber.com, easy one. So, I mean, I've got my LinkedIn profile as well. We are pretty active just at most marketing events. We're going to have a sizable presence at places like RSA and Black Hat and those kind of typical conferences. So if you happen to be at a large conference, chances are you'll see a booth of ours that you can talk to us about, or you can go to our website and we can do demo, do a POC, whatever. It is a really fun solution to play around with.
Sweet. Paul, thanks for joining me today and giving our listeners an entertaining wrap up on the vulnerability ups and downs of 2022. This was great.
Cool. Thanks, Chris.
And as always, like to thank everyone at home and at work for listening to and watching the CyberWork podcast on an unprecedented scale in 2022. We've doubled, nearly tripled our numbers, and we're delighted to have you along for the ride. So before I go, I just wanted to say, go to infosecinstitute.com/free to get your free cybersecurity talent development ebook. It's got an in-depth training plans for the 12 most common roles, including SOC analyst, penetration tester, cloud security engineer, information risk analyst, privacy manager, secure coder, and more. We took notes from employers and a team of subject matter experts to build training plans that align with the most in-demand skills. You can use these plans as is or customize them to create a unique training plan that aligns with your own unique career goals. So one more time, just go to infosecinstitute.com/free or click the link in the description that I'm assuming is down there to get your free training plans, plus many more free resources for CyberWork listeners. Thank you once again to Paul Giorgi. Thank you all for a great 2022, and thank you so much for watching and listening. And we will speak to you next week.